Good morning, class. Today I'm going to go over scatter plots. Let's go over scatter plots. Okay. All right, here we go. Okay, please make sure that you go to the page. Well, you already know kind of where to go. You are here for your EOG review, and this is the one that we're working on right here. Okay, well, sorry, we're working on number 4. We're working on number 4, scatter plots and lines of best fit. Okay, that's what we're working on. So I'm gonna go here and I'm gonna show you what to do. Okay, please have your calculator ready. Please have your calculator ready. We're gonna clear our calculator. Super important. Second plus 712. Okay. All right, good people. Here we go. Okay, move this stuff out the way. Okay, so a scatter plot, first of all, is a graph that determines whether relationship between, well, it compares two quantities. Let's just keep it short and simple. It compares two quantities to each other, okay? It could be age and height or weight and, a person's grade. Not that that's not a good correlation there because a person's grade doesn't have anything to do with their age or their height. But nonetheless, it compares two quantities. When you see a scatter plot where the points are going up, this is a positive correlation. That means as x increases and x is always going to increase, y is also increasing as well. When you see points going down, that means your x is increasing and x always increasing, but your y values are decreasing. That's what gives you, this is important right here, but your y values are decreasing. So that means that this is a negative correlation. X is always going to increase because X is, just think of X as like time. It's usually minutes, days, years. Those variables are unaffected by anything else. They're going to increase regardless. So, and as you read the x-axis, you read the x-axis from left to right, okay? So, or you read a graph from left to right. So your x-axis or your x values are always just going to increase. All right, look at a scatter plot. It looks like this. When your points, you can't tell if the points are going up or if the points are going down. This is a no correlation. Okay, and remember the word correlation is the relationship between points. So these are the different types of scatter plots that you're going to see. So here, now we're going to determine whether the scatter plot of the data would be a positive, negative, or no correlation. Okay, so let's look at this in the first one. If you were to graph height and test scores, okay, height being your X and your test scores being your Y. If you were to graph that X and Y, your height here and your test scores here, your height has absolutely nothing to do with your test scores. They don't have a correlation with each other. So just because I'm short doesn't mean I'm going to make a good grade, or just because I'm tall over here doesn't mean I'm going to make a bad grade or a good grade. So this has no correlation. They are unrelated to each other, okay? Right here, your temperature and your cooking time, okay? Your temperature and your cooking time. So this is your X, this is your Y, okay? The higher your temperature is, as your temperature increases, your cooking time is going to decrease because it's going to cook faster, right? Because you need the temperature or heat in order to cook something in the stove or cook something in general. So as your X increases or as your temperature increases, your cooking time decreases. So this is a negative correlation. This is a negative correlation. As temperature increases, your cooking time decreases, okay? Years of education and income. This is X, this is Y. So as your years of education increase, the more education you have, on average, not all the time, your income is also going to increase. So as X increases, Y increases. This is a positive correlation. And you know, there's always exceptions to the rule. That's why it's called a scatter plot, because your points are not going to form a perfect straight line. So this is a positive correlation. Okay. Um, as your speed increases, this is X, this is Y. As your speed increases, your distance covered is going to increase also. Over time, the more distance you've traveled as your speed increases. Okay, so this is another example of a positive correlation. All right, now let's look at lines of best fit. If there's a strong linear relationship between the variables, a line of best fit can generally describe the tendency of that data. So your line of best fit is the line, just like you see the line here, that best describes the points. You see, this line best describes the points because the line is in the center of the data. You have almost the same amount of points on top of the line as below the line, and it's going in the same direction. You wouldn't draw a line of best fit for this line by going down because these points are going up. You wouldn't draw it under the points. You would draw it in the middle of the points because you want a line that best describes the points. So the line that best describes the points is going to be a line that's in the middle of the data, that's going in the same direction as the data or the points. Okay. All right. So we're going to do this as an example here. It says make a scatter plot in the table. Okay. So we're going to graph these ordered pairs down here. Okay. So let's do that. When we graph them, we got 1 and 2. Actually, we're going to graph these in the calculator. I know how to do that. So we got stat. And I do want you to graph this, but do this when you do the graph this on your own, okay? So make sure before you submit that you graph this on your own, but I am going to graph it in the graph. All right, so I cleared my calculator already, and I go here. I press enter on edit, and I'm going to type these ordered pairs in. I'm going to type these points in L1 and these points in L2. Well, numbers in L2. Sorry, y'all. Sorry. I'm going to type these numbers in L1 for your X, and I'm going to type your Y values in L2. Okay? So these are my ordered pairs. This is 1, 2, this is 1, 3, this is 2, 4, this is 3, so on and so forth. Those are my ordered pairs. When the table's sideways, you read your ordered pairs this way. All right, so I have 1, enter, 1, enter, 2, enter, 3, enter, 3, enter, 4, can't see me press enter, enter, 5, enter, 5, enter, 6, enter. Okay? Just a little bit. All right. Now move my arrow over, and I'm going to put these numbers in. That's 2, and then enter, 3, enter, 4, enter, or I could press the down arrow to go to the next line. 4, enter, 5, enter, 5, enter, 7, enter, and 8, enter. Oops, I missed the number. Let's go back. It happens from time to time, don't it? So you got 2 there. You got 1 and 3. You got 2 and 4. You got 3 and 4. You got 3 and 5. Wait a minute. Yeah. You got 4 and 5. Then we have 5 and 5. That's what I was missing. Then I got 5 and 7. And then I got 6 and 8. There we go. Okay. All right. Always make sure to double check to make sure that you have all your points typed in. Okay. All right. So now I'm going to go to second stat. And I'm going to cut this plot on, cut it on. Okay. And now I'm going to graph it. And there's my scatter plot. Okay. And I don't need all this space here, so I'm going to change my window range. Or I could just do zoom fit, see what zoom fit give me. Okay. All right, it gives me the same thing. But if I wanna, let's see, I don't want to go down so far. So let's just go down to -2. See, look at what this does. See, let's go, it went over to -2. I said the wrong thing. I said down, sorry. And then let's go to Y. Instead of going down -10, let's not go down so far. There you go. Okay. All right. So it kind of looks like this graph over here. Okay. So now I have a scatter plot. All right. Now it says describe the correlation. Look at this. Your points look like they're going up. So this is a positive correlation. So for this one, this is more of a positive correlation. Okay. All right. As X increases, Y also is increasing. And I can kind of look at the table to tell as well. The data has a positive correlation. Okay. So its slope should be positive. Okay. So now let's plot the data. We did that here. Now we're going to sketch a line. We're going to sketch a line of best fit. I'm going to show you how to do a line of best fit in the calculator. So to do your line of best fit in the calculator, you go back to stat. You're already, see how you already have your points typed in? Leave them there. Go to stat and you go over to calc and go down to lean rig. You see right here, lean rig? Now look at these keystrokes because I want to type in, I want my line of best fit to show up on my graph. So it's super important I do this right. I press second, 1, comma, second, 2, commas right here. And now I'm going to press, you see where it says vars? I'm going to press vars, Y bars, and now I'm going to press enter 3 times. 1, 2, 3. Okay? So now, when I go to y equals, my equation is already there. So then when I go to graph, there's my good old line of best fit. You see it? Okay. So now this is the best, the calculator will do a better line of best fit than you could ever do. So that's a good idea to do that. Okay. So we sketched the line of best fit in the calculator. It says identify 2 points, okay, and then find the slope. All right, so look, we did it in the calculator, this right here. And so now I'm going to write the line of best fit here, go to y equals, or I could go back to the main, screen. So I got y is equal to, and I'm around it, this is point 948, okay, and I'm put 949 x, okay, plus 1.615. We're going to round it to the thousands place, 3 spaces behind the decimal. Okay? And this is your line of best fit in the calculator. All right. Okay. Don't forget to graph these points before you submit. So let's look at this. We're going to do the same thing again. Here, it's saying example number 2. I want you to graph the points here. Okay. It says the 2 sets of data in the table are related, relate to the average lifespan of various animals in the zoo and their maximum lifespan. So longevity years. So this is their age and this is their maximum lifespan. Create a scatter plot. So we're going to do the same process again. I am going to clear my calculator. Second plus 712. Okay. And I'm going to go back to stat and I'm going to type in the points at edit. And let's type in these points, okay? Oops. Okay, so I'm going to type my L1 values, my X values, in L1 and my Y values in L2. Okay. All right, so the first is 5, enter, 10, enter, or to use the down, 20, 25, 35, and 45. Okay, and go over. So now we have 35, 40, 50, 60, 65, 75. Please type this in your calculator so you'll get practice because you'll have to do this stuff on your own, okay? Now we're going to go second, y equals, and we're going to cut the plot on again, press enter, okay? Put everything on. Now all I'm going to do, you see how my numbers, I have larger numbers, so if I just graph it like that, I'm not going to see my numbers because the highest it goes up, this goes up, this goes over to 10, this goes over to 10, up 10, 10. So I'm really not going to see any of these numbers. You see how I don't see them? So what I'm going to do is see if Zoom Fit will work for this. It may or may not. May have to just change my window range. Okay, you see how I didn't? So I'm going to change my window. Look, I'm going to use the window that they have right here. Look at what they have along the x-axis. They go from 0 to 45. So I'm going to go from 0 to my min, and my max on the x-axis is 45. And look at what it goes up by. It's going up by 5. So I'm going to put 5 here. Now look at my y. My smallest y value is 0. So I'm going to put 0 here. Y min. My highest y value is 80. So I'm going to put 80 here. Okay. And this is going up by 10s. Okay. And I leave x rest alone. So now I can graph it. Okay, and there's my scatter plot right there. You see how this point is on the edge? So let me fix that. Let's go instead of, because the last you see the highest x value is 45. So let's go out to 50, just so I can see that order pair. See, that makes it better. So now I can see all my points very well. Okay, so I'll need you to graph those points here as well. Don't forget to do that before you submit this assignment. All right, so now we're going to draw a line of best fit. We're going to draw a line of best fit in the calculator. So look, this is what we have. We go back to stat. Our points are already there. We're going to go over to calculate. Go down to lean red. Watch this process again, okay? Because I want my line to show up on my graph. So I press second, 1, comma, second, 2. I'm pressing the number 2, okay? Then comma again. Then look, I go back to where bars, got bars, Y bars, and press enter 3 times. Enter, enter, enter. Okay? So this is my line of best fit. You see how it puts those keystrokes automatically put the equation here. And then when I graph it, the calculator does the best line of best fit. It really does, okay? So I'm going to write that line of best fit down, but I'm going to end up rounding it. I'll go back to my main screen. I'm going to round this, okay? So my slope is, I don't want to just put 1. I'm going to put 1.007, okay? So y is equal to 1.007x. I'm rounding it. And then plus 30.662 plus 30.662. Okay, this is the line of best fit here. All right, so now we use this line of best fit. So we got a line of best fit. Predict the maximum longevity for an animal whose average longevity is 15 years. So longevity years. So average longevity is X. You see how this is average longevity? So they gave us the X value, and the X value is 15. So now we need to figure out what the Y value is, okay? Because they want, let's see, the maximum longevity. Maximum longevity is Y. So we're going to plug in 15 for X to see what this Y value would be, the maximum longevity, all right? So, when I plug in 15 here, go back to my main screen, this gives me 1.007, and we have times, I'm gonna put 15 in this place, 15 plus 30.66, oops, sorry. Here, start again because you couldn't see it. I'm plugging in 15 here. Okay, to figure out what my Y value is. And then here, my X value is 50. I'm going to plug in 50 for that one. So now, I'm going to plug in 50 to get this answer. Okay? Okay. All right, so let's do it. Type this in, slide this up a little bit so you can see it. So I have 1.007 times 15 plus 30.662. Okay? Enter. So round to the nearest whole number. This is about 40, this is about 46. So it's going to be about 46 years, okay? So they live to be about 46 years old. Okay, this animal lives to be about 46. So put 46 here. So let's say the other one is 50. The max here is what? So let's type this in. 1.007 times 50 plus 30.662. Okay, so that's going to be about 81 years. Ooh, it's good, ain't it? 81 years. So this is 81. Okay, all right. So now let's look at doing predictions with the line of best fit from the previous, let's see. The line of best fit found in the previous section of the equation was y is equal to 1007x plus 30.662. Okay? All right, so let's look to see. Now we're going to make predictions. We're going to by using a line of best fit. So we have a line of best fit, and now we're going to make predictions. They're either going to give us X or they're going to give us Y. And we substitute those values in and see what we get as our answer. It says, what would the value of Y be when X reaches 20? So we're going to plug in 20 for X. So we got Y is equal to 1.007 times 20 plus, we have 30.662 or 662. Okay, so let's type this in. 1.007 times 20 plus 30.662. Okay, and so this is going to be y is equal to about 51. Okay, all right, and because we're rounding it to the nearest whole number, because we don't want part of the age, right? All right, so let's look at this one. What would be the y value if x is 43? So now we're going to plug in 43. Y is equal to 1.007 times 43 plus 30.662. Okay? All right, so here we got 1.007 times 43 plus 30.662. All right, so this is about 73.74. Okay. All right. So now let's look at here, down at the bottom. It says this scatter plot shows the cost of a single unit product relates to a number of units um, of that product that are sold. So we got units sold in hundreds, and we got the price in dollars. So look at this. The units sold in hundred, as it increases, the price in dollars decrease. Okay. So the line of best fit drawn through the data. What would you predict the cost of the unit was when they still hadn't sold their first unit yet? So the starting amount when it is right here, you see, when they hadn't sold the first unit yet, it was $40. So right here is 40. The price was 40. Okay. How many units would need to be sold for the price per unit to be $12? So price, uh, let's see, per $12. How many units would need to be sold for the price per unit? Where's the price per? Okay, units sold. There's a unit sold here. So we got 12 is here. Okay, so how many units would need to be sold? So let's go 12 and let's go all the way over here, perhaps maybe somewhere in here. So it would be about maybe 14, that 14,000. And that's because it's 12, it's the price. Yeah, so 14,000. All right, so this will be your answer here. See how I'm making a prediction by using the line of best fit? So if I go to 12, the line would be way over here. So this would be about 14 right in here. Okay. All right. Go ahead, make sure that you graph those two graphs there, and see if you can draw a line of best fit and then submit this assignment, okay? And your line of best fit that you draw for both of those graphs should be a line that goes through the center of the data, okay? All right. All right, guys. Hope you have a great day. Please make sure that you work on your makeup work. If you have makeup work, please do that and submit this assignment. Have a good one.